Hey everyone, welcome back. So we're going to discuss today how do we get that sediment from the last mini lecture into rock form. So let's talk for a second about lithification as a process. So, oh, sorry, you'll see a little slash there where I thought my hand could swipe the slides aside. That did not work. So lithification, how does sediment actually turn into sedimentary rock? Because we heard the term lithification when we discussed the rock cycle, but now we're actually going to get into, okay, what is this? So, when you have sand grains, it's a little different depending on the type of grain you're dealing with. We usually talk about sand grains first, and then we'll talk about clay particles because they're a little different in how they come together. So sand grains will pile up over time, and then the sand grains that are on the bottom of these big pileups, they undergo a lot of pressure, so they get compacted a little bit. They don't fit together tightly, so that leaves some pore spaces available, and those are usually filled with air or water. And over time, they'll get sort of pressed together and the air or water will be expelled, so it gets a little thinner. This drawing is actually a little exaggerated. It doesn't compact that much. And so the process is a little different when you're dealing with clay because clay is actually much more compactable. So clay particles, the really fine ones, they'll sit at different orientations and they'll have pore space, they'll have water in there. But when you compact them, because the clay particles are actually kind of like little sheets or little dinner plates, when they compact, they'll all kind of align or line up together, and they're much more compressible than sand grains. So you'll usually be able to compact way more grains into space when you're talking about clay than if you're talking about sand. And when you're actually talking about the cementing process, how do the sand grains actually stay together? Well, that water that was sitting between the sand grains, that was usually carrying minerals. And as it's squeezed out, it leaves behind the minerals, and those act as like a binding agent. So there are a couple of natural cements. There's 4 main types that are typically dissolved in the water and that kind of are left behind. Calcite, silica, and iron oxides. So calcite, quartz, and hematite is another way of describing those. Those are the ones you're typically going to see acting as cementing agents in sand. They chemically bind together. So calcite or calcium carbonate, that's usually common in sandstone and other sedimentary rocks. It does okay, but if it's the binding agent, it can be crumbly. The geology term for crumbly is actually called friable, Friable. I'll write it here. That's our crumbly term. Silica, if it's the binding agents, can bind some sandstone and other sedimentary rocks. It's really strong. So if your sedimentary rock is particularly resistant, then it's going to be really strongly bound by silica. Clay minerals, to kind of jump around here, sorry, let me actually just talk about iron oxide. So iron oxide minerals like hematite, you're going to know if that's your cementing agent because those have a reddish color when they oxidize. So typically your stuff like sandstone can be bound by things like calcite, quartz, which is silica, or iron oxide, which is hematite. Now, clay minerals themselves kind of cement themselves. So clay is its own cement. So when you get clay particles and they're coming together, they can actually just act as the cementing agent as well. Or you can have a mixture of clay minerals and sand grains, and the clay minerals can actually act as the cement in the sand grains. So that's actually the process of lithification. So now we kind of know how things lithify. So let's talk about some common sedimentary rocks. I'm going to break it down by the size of the class. So we've had, we've had gravel size class. So let's focus in on that. So we can have boulders, cobbles, pebbles, or granules. But generally speaking, if you've got big clasts in your rock, you've got gravel. So the 2 of the common ones we're going to deal with, one is conglomerate, and that's when the clasts are kind of rounded. It's mostly the background material there is mostly quartz sand. So the quartz in there, that silica, that can be that binding agent that we talked about, the cementing agent. This is a picture from the Roosevelt Dam in Arizona. If your particles are more angular, that usually leads to something called breccia. So we also include these scales here to give you a sense for how large those particles are. So occasionally in images like this, pay attention to the scale. It can be kind of important. Okay, so that's gravel. Well, what if we have sand? Sand actually gives us a little more variety, despite the fact that it's only that one size range. But if you've got some medium or fine grained stuff, then that can give you different outcomes. So sandstone is your typical sedimentary rock form from sand. Makes sense, right? It's usually got better defined layers than conglomerate or breccia because it's a little more easy to align. Conglomerate and breccia, because they're made of bigger clasts, they're harder to get all those clasts to line up in a neat way. So there's a couple of different types of sandstone that we encounter. If your rock has, it's about 25% feldspar grains, it's called an arkose. And that's usually a giveaway, is that it's got these like cream colored particles or kind of pinkish particles like here, a couple of these redder ones here. This is usually a sign that you've got arkose. What that means is that feldspar is an indicative that the sediment came from crystalline rocks and then it was rapidly buried. I'm gonna need just a second here. My computer's been a little weird. There we go. You couldn't see what was happening, but my computer just tried to shut off. If we've got another variety of sandstone, let's say we've got mostly, not feldspar grains, but let's say we've got a lot of quartz in there, then we're dealing with something called, actually, sorry, I'm jumping around, but let's say you've got multiple compositions. You've got quartz, you've got feldspar, you've got iron oxide, mica. Let's say you've got a big mix of sand-sized particles. That's usually called gray whack. And you can tell because it doesn't look like it has a consistent color. It looks like it has a lot of different types of grains in there. If you've got one particular grain made of quartz, then you've got quartz sandstone. It's that this reddish color is a big giveaway here. There are a couple things you can kind of figure out if you've got quartz sandstone, because quartz is not necessarily, well, it's pretty common, but if you've got pretty exclusively quartz sandstone, then the source for the material was already very quartz rich, like another sandstone, or you had a specific type of weathering that really exclusively picked out the weaker minerals like feldspar and mica and carried them away, which left behind the quartz. So you might have a really quartz heavy source, or this quartz sandstone might be the leftovers from a rock that had weaker stuff in it that got carried away. Either way, the size distribution is sand. That's the particles we're looking at. Well, if we've got mud-sized particles, the really tiny ones, we could have silt or clay. It's kind of easy to figure out if you've got silt because you're going to be dealing with a siltstone. Silt-sized particles, generally made of quartz, is going to form your siltstone. Those are usually going to form really thin layers. So things like silt and clay are made of these little like sheet size, like their particles are really tiny and they're like little dinner plates. So you usually get these really fine grained layers because when they're compacted, they form these really, really nice layers. So your siltstone is going to be formed from silt, and it's usually going to feel a little more coarse in your hand. Remember, we talked in the past that silt and clay are different because silt is quartzy, which means it feels like sandpaper, and clay is sourced from things like fine-grained clay minerals, and they're going to feel a little more slippery. So when you've got something like clay minerals instead of quartz, and they're at the size of clay, then you're going to deal with something called shale. And that really is really, really easily eroded. Shale is really flaky, it breaks off really easily, and it's quite weak to erosion. So shale is usually easily eroded. Okay, so I think that does it for this little mini video. So the associated textbook reading is 7.5 if you'd prefer to read that. If not, you can just watch this video and fill out the questions online, and I'll see everybody in class in the next few days.